Okay, back to the video. So I input my quotient in there, and now, of course, you can look at it if you want to as all of these different integrals. I'm going to pull that -9 out. And I'm going to go ahead and add a page here like I did before. And we will continue this down here. So this is going to be x cubed minus 2x squared plus 6x minus 9 times the natural log of the absolute value of x plus 4 plus c. So we were almost done with that one. I just wasn't able to finish the whole thing, but that is it finished. So basically you're doing that long division to get the equivalency, and once you've done that, then it's nice, easy integration. This one, the degree of the numerator is equal to the degree of the denominator. So when we have a situation like that, we're also going to do long division. So what can I multiply 2x by? That will give me x. That would be 1/2. So 1/2 times 2x is x. 1/2 times -2 is -1. But then you subtract, so minus, and that becomes a plus. And that goes away. This is -4. So this would be -4 divided by 2x minus 2. So that's equivalent. And so we'll split that up into two separate integrals. And I'll go ahead and factor a 2 out of that denominator and bring that out front also. I know this is going to be 1/2 x, but when I bring that 2 out, this becomes 1/2 x minus 2 times the natural log. That made it worse. Of x minus 1 plus c. And if you wanted to, I could say, or 1/2 x, because you might see this, you might see it this way on a multiple choice to the second power, right? You could bring that 2 up as the argument's power. So that's another way to write that. Okay. And then number 7, the degree of the numerator is greater than the degree of the denominator. So we're going to do long division. Now, I'm just going to put these in, or actually there's only one of them, just in case we need it. So what times x gives me x cubed? That would be x squared. So x squared times x cubed, x squared times -1, negative x squared. Then we subtract. So that goes away. And that leaves us with a positive x squared. Bring down your plus x. What times x is x squared? That would be x. So x times x squared. X times -1, negative x. Then we subtract. That goes away. This one becomes 2x. What times x is 2x? 2. So we got 2x and then minus 2, but we subtract. So it actually ends up being a positive 2. So this is plus 2 over x minus 1. So that divided by that is equivalent to x squared plus x plus 2 plus 2 over x minus 1 dx. Excuse me. And so this would be 1/3 x to the third plus 1/2 x squared plus 2x plus 2 times the natural log of the absolute value of x minus 1 plus c. That is an acceptable answer. Or 1/3 x cubed plus 1/2 x squared plus 2x plus the natural log of the absolute value of x minus 1 squared plus c. So that's cleaning up that logarithm. Okay, I'm going to switch colors again. I'm going to do green this time. Degree of the numerator is greater than the degree of the denominator, so we're going to do long division. What times x squared is 2x cubed? That would be 2x. So that gives me 2x cubed plus 4x squared minus 6x. But then I subtract. So that turns to minus, that turns to minus, that turns to plus. This goes away. Negative 3x squared minus 5x, bring down my plus 20. And then negative 3 gives me negative 3x squared minus 6x plus 9. But then I subtract, which gives me a positive here, and a negative there. So that one goes away. This is a positive x and a positive 11. And so I'm done with that. So I say plus x plus 11 over x squared plus 2x minus 3. And so now that's what I'm integrating. 2x minus 3 plus x plus 11 over x squared plus 2x minus 3 dx. And since I can factor my denominator, I'm going to go ahead and say, well, this is going to be x squared minus 3x plus, and I'm going to go ahead and do this integral x plus 11 over, and I know that the derivative of my denominator is not x plus 11, so I couldn't do that. I couldn't use u substitution. But this one I can use a positive 3 and a negative 1. And I can use my partial fractions on that. So I'm going to bring this down. We've got x squared minus 3x plus, and we want this to be a over x plus 3 plus b over x minus 1. And our side work a times x minus 1 plus b times x plus 3 equals x plus 11. And so if x is 1, then I have a goes away. I get 4b equals 1 plus 11. And so my b is 3. If x equals negative 3, my b goes away. I have negative 4 times a equals 8. So a is negative 2. So So this is going to become x squared plus 3x plus, and then this would be the integral of negative 2 over x plus 3 plus 3 over x minus 1 dx. I got my dx over here. So x squared plus 3x. I'm going to bring the negative 2 out and separate these into two separate integrals. Bring that positive 3 out. Now I've got x squared plus 3x minus 2 times the natural log of the absolute value of x plus 3 plus 3 times the natural log of the absolute value of x minus 1 plus c. And we've got two ln's this time, and one is negative and one's positive. So, I mean, you could do like what I did here and just put a squared and a third, but you could also say absolute value of x minus 1 to the third over absolute value of x plus 3 squared. That doesn't have to be, that can be that, plus c. Okay, so there's actually a few different ways to write this answer. You could have left the answer like this. You could have written it like that. You also could have written it like I was doing with the other ones, oops, and just leave it as the minus ln of the absolute value of x plus 3 squared plus ln absolute value of x minus 1 to the third power. So 3 different ways to write that answer. Or, okay. And now example number 9. So this one, find a u substitution to use partial fraction decomposition. And so for this one, think about how could I get something times something down here. If I let my u be cosine x, this would actually be sine x over u times u plus 1. And then my du would be negative sine x dx. And so du divided by negative sine x would be my dx. So if I put that du divided by negative sine x, and my sine x is canceled, I would end up with, I'll bring the negative out front, 1 over u times u plus 1 du. And the other thing you could do is just make your negative be up here, and when you try to make this into your a over u plus b over u plus 1, your side work for your partial fractions would be a times u plus 1 plus b times u equals negative 1. And then you wouldn't have to worry about that negative, so let's just go ahead and do that. Now, if u equals negative 1, my a goes away. I've got negative b equals negative 1, so b is 1. If my u equals 0, my b goes away. I get 1a equals negative 1. And so that gives me the integral of negative 1 over u plus 1 over u plus 1 du. So this is negative ln absolute value of u plus ln absolute value of u plus 1 plus c. And now let's put our u back in. And that's your answer. And again, you know, you could choose to say ln of absolute value of cosine x plus 1 over absolute value of cosine x plus c. with that being your whole argument. So that's another way to write that, just in case you're needing to look for that on a multiple choice question. And then on example number 10, again, looking for U substitution, and I'll do this in a different color. Do it in navy. If I let my U be e to the x, this would become U over, now think about this. This would be U squared minus 1, because that would be e to the x squared. And then your du is e to the x dx, so du divided by e to the x. Oh, this will go away. So I don't need that to be a u because it's going to cancel. Now this is going to be u minus 1 times u plus 1. So this is going to be a over u minus 1. It doesn't matter if you put the a over u plus 1 and I put the a over u minus 1. Either way, you're going to come out with the correct answer if you do the problem correctly. So this is a times u plus 1 plus b times u minus 1 has to equal 1. So if your u is negative 1, then negative 2b equals 1, b equals negative 1/2. And if your u is 1, then 2a equals 1, a equals 1/2. So this becomes 1/2 over u minus 1. I'm just going to say du plus negative 1/2 over u plus 1 du. So of course pull that 1/2 out front. And that I probably would make a minus. And so that would be 1/2 times the natural log of the absolute value of u minus 1 minus 1/2 times the absolute value of u plus 1 plus c. So that's one answer. Or and actually they're both to the 1/2, so you could put this on the outside if you wanted to. There's so many different ways to write this, but since they're both being taken to the 1/2 power, you could do that. You could leave the 1/2 out in front and just take those, oh, we forgot to put our u back in, sorry. I just realized that. So you could leave the 1/2 out in front and do it like that. So that's what this one should have been. So I took that thing off of there. And this one will go to here so that you can see that we put that back on. And these u's need to be e to the x's. E to the x minus 1 over e to the x plus 1, okay? So these are, all the different ways that you could write that answer. And any of those would work.